All right, let's talk about circles. So in this lesson, we are going to write equations of circles and we are going to graph circles. So we all know what a circle is, right? But by definition, a circle is a set of all points, x comma y, that are equidistant from a fixed point called the center of the circle. So if you look here, there's a picture of a circle, right? Here's a picture of a circle. This is the center. All of these points, this point, this point, this point, this point, this point, they're all the same distance from that point, right? That's how you get a circle. That distance, r, between the center and a fixed point xy is called the radius, right? So once again, this is our center right here. This is r, our radius. And then this is any point x comma y. So all of those points are different points, but they all, we can look at them all as x comma y. All right, so what we get from this is we can write an equation of a circle. The equation is actually derived from the distance formula, okay? So if we call the center h comma k, and then we do the distance formula, which is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, we get r is equal to the square root of x minus h squared plus y minus k squared. To make it a little bit easier on ourselves, we square both sides and we end up with our equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared, where r is your radius, so that right there is your radius, and then hk is the center. Okay, so we're gonna fill that in here. Hk is our center, and r is our radius. Notice in the equation, it's x minus h, y minus k. So a lot of times people just say, oh, you take the opposite of what you physically see in that set of parentheses. Okay, so now what we're gonna do is we are going to graph the equation. We only have two of them because it's pretty simple. It has to be in that standard form, so this standard form right here, okay? All right, so this one's ready to go right now. We need the center and we need the radius. So this is r squared, remember? So we take the square root of that, which is 5. And then to get the center, this is a +1, so we take the opposite of that. That's a -1. And then what's being subtracted off of y? 3. And now we can graph that circle. So we're going to graph the center, which is -1, 3. And then we are going to get 4 more points that are 5 away from the center. So that's how big the radius is. So we're going to go 5 to the right of that point. We'll end up at 4. We'll go 5 to the left of that point. We'll be at -6. We'll go 5 above, and obviously -6 comma 3, but I'm just saying the horizontal distance. We're going to go 5 above that point. So I'm at 3, 5 above is 8. And then I'm going to go 5 below that, which is at -2. And yes, you can just count, but I like to just think about where it's going. Connect those points together, right? And hold for a second and it'll make a nice little circle for you. All right, if you look at this one right here, this is not in standard form. I see the x squared and the y squared and I see the plus sign. But if you look at the standard form of a circle, our lead coefficients on the x and the y, or the coefficients on x and y, are 1. So in order to get this to be a 1, what we're gonna have to do is we're gonna have to divide. We're gonna divide both sides of the equation by 2. That means, remember, divide everything by 2, not just the first term. And we get x squared plus y squared is equal to 9. All right, so you can see our center is, nothing is subtracting off of x, nothing is subtracted off of y, so 0, 0. And our radius is 3, because r squared is 9. So once again, graphing, 0, 0 is our center, 3 to the right of that, 3 to the left of that, 3 above, 3 down. Connect those 4 points to make your circle. Oh my goodness, that is gorgeous. Okay, be a little, there we go. All right. Okay, so now what we're gonna do is we're gonna do vice versa. We'll write equations of circles. So write the standard form of the equation of a circle with the given radius and the given center. Okay, so if the center is 0, 0, there's nothing subtracted off of x, so it's x squared, always a plus sign. Nothing subtracted off of y, so y squared equals, and then remember it's r squared, so squaring 4, you get 16. All right, x minus a -4, so that becomes +4 squared, plus sign. Y minus 3 quantity squared is equal to 9 squared is 81. This one here, x minus 2 quantity squared plus y minus 3 halves quantity squared is equal to, and then r squared, so root 7 squared. Remember when you square square root, you're multiplying it by itself. So root 7 times root 7 is root 49, which is 7. Or just remember that they're inverse operations, so they cancel each other out. And we just get 7. Okay, so let's also talk about that term in the middle there. That term in the middle, the y minus 3 halves quantity squared. You might be asking yourself, do we have to write it as the 2x minus y? And you don't. You can leave it like that because it's helping you find your center. Okay. Next, it's write the equation of a circle with center negative 3, 5 passing through the point 4, 2. So here's what you need to remember. To write an equation of a circle, you need two things. You need the center and you need the radius. So if you look right here, I already have the center. The center is negative 3, 5. That's h, that's k. So what I can do is I can start to write my equation of my circle. X plus 3 quantities squared plus y minus 5 quantities squared is equal to, and then I need the radius, which I wasn't given. So there's two ways to get this radius. Okay, there's two ways to get this radius. One, you can use the distance formula. So you can find the distance between these 2 points, okay, which is the long way, so I don't want to do it that way. Or I can remember that this is a point on the circle. So when I plug this in for x and I plug this in for y, this has to give me what it's equal to. So that's what I'm going to do. So off to the side, so what I'm going to do here to ensure my right answer is I'm going to box this and be like, okay, that's going to be part of my final answer. I'm plugging in 4 for x and 2 for y. So I have 4 plus 3 squared plus 2 minus 5 quantity squared is equal to, and I'm going to figure out what that's equal to, and that number goes right here, okay? This is the distance formula right here, like that's the distance formula, and then that would just give us r, and we have to square it. So realize this is just the shortcut to the distance formula. Okay, so 4 plus 3 is 7, 7 squared is 49. 2 minus 5 is negative 3. Negative 3 squared is positive 9. These two numbers should always be positive because you're squaring a number. And we get 58. So we're going to put a 58 right here. And that's r squared. So the radius is square root of 58. R squared is 58. All right, here's the next one. Write the equation of a circle with the center at the origin. So that's x squared plus y squared. Equals. And then once again, I'm going to box this because I'm almost done. And then passing through 0, negative 3. So this is an easier one because the origin is 0, 0. So if it passes through 0, negative 3, that means the radius is 3 and r squared is 9. But another way you can look at it is plug in 0 for x, you get 0. Plug in negative 3 for y, you get 9. 0 plus 3, or sorry, 0 plus 9 is 9. All right, why don't you pause the video and try this one? All right, center, this is hk. At 1, negative 2, so that's x minus 1 quantity squared plus y plus 2 quantity squared is equal to, this is going to end up being my answer right here, and now I'm going to plug in 4 for x and 6 for y. Plugging in 4 for x, I have 4 minus 1, which is 3, 3 squared, which is 9, plus plugging in 6 for y, 6 plus 2 is 8, 8 squared is 64, 9 plus 64 is 73. So r squared 73, the radius is root 73. Are we good? Great. I'd assume so. Okay, next it's write the equation of a line that is tangent to the circle x minus 2 quantity squared plus y plus 5 quantity squared equals 17 at the point 3, negative 1. Okay, so let's dissect this question or this prompt. Write an equation of a line. So we know that an equation of a line looks like y minus y1 is equal to m times x minus x1. All right, now I gave point slope because remember point slope is the easiest form to use because you can use any point in the slope. If you try to force yourself to use y-intercept, if you don't have the y-intercept, which we don't, then it is much more difficult. Okay, so what I'm going to do is I'm going to draw a picture of what this looks like so that we can start to imagine what the heck we're doing here. So we have a circle, and here's my circle, okay? They gave us the center is 2, -5. So I'm going to draw a point right here, and I'm going to label it. I'm going to say you are 2, -5. Okay? All right, and then I am given another point that's on the circle, which is 3, -1. So 3, -1, let's say that's like right here, okay? And it doesn't have to be accurate. This is just a sketch, okay? All right, so now I want to write an equation of the line that's tangent to the circle at that point. So let's draw a line that's tangent at that point. So remember, it means it only crosses or hits the circle once, and it's at that point. So we want to write an equation of this red line right here, okay? To write an equation of a line, you need two things. You need a point, 3, -1, we have that. But we also need the slope of that line, which we do not have the slope of that line right now. You need 2 points to find the slope of a line, and I don't have 2 points on that line. But I do have 2 points. I have these 2 points, all right? So I can find the slope of that line. So what we need to know is a fact. A fact is that that's a radius, the pink line, the pink segment, and the red line is a tangent line. Radiuses and tangent lines are always perpendicular. So if I can find the slope of the radius, then I can find the slope of the tangent line. All right, so let's find the slope of the radius. So to keep this organized here, I'm going to say the slope of the radius. Okay, M is for slope, radius is the R. All right, so I'm going to do y2 minus y1. So y2 is -1 minus y1, which is a -5. Double negative makes a positive. Over x2 minus x1, 3 minus 2. All right, we get -4 over 1. Sorry, +4. Come on, Jill. +4 over 1, which is 4. So the slope of the radius is 4. So if I want the slope of the tangent line, the slope of the tangent line is perpendicular to that. So I need the opposite reciprocal of 4. The opposite is negative. The reciprocal of 4 is 1/4. Okay, so now I have enough information to write the equation of the line because I need a point on the line. Make sure you're picking the point on the line and not the center of the circle. This is the point on the line, and I have the slope. So we're going to do y minus y1, which is a -1, so that's +1, equals m, which is -1/4, times x minus x1, 3. So there's your answer. There's your equation of your line. This is in point-slope form. If it asks us for slope-intercept form, then you would have to distribute your -1/4 and add 1 to both sides. So let's also get slope-intercept form in case we are asked for it, okay? So if we distribute our -1/4, we have y plus 1 is equal to -1/4 x plus 3/4. -1/4 times -3 is 3/4. And then subtract 1 from both sides. And we have y equals -1/4 x minus 1/4. So this right here is slope-intercept form. Now, it just asked me for an equation of a line, so the first one was fine, but just for future reference. Wink, wink, nudge, nudge. All right, why don't you pause the video and try the next one? All right, so I'm going to do a quick sketch right here. Okay, here's the center. 0, 0. 3, 4. I'm just going to say it's right there. It doesn't have to be accurate. All right, I have my point already. It's 3, 4. I need the tangent line, right? Here's the radius, perpendicular. So slope of the radius is equal to y2 minus y1. It doesn't matter which one's y2 and which one's y1. You can do 4 minus 0 or 0 minus 4, just as long as you're consistent. 4 minus 0 over 3 minus 0 is 4/3. Slope of the tangent line is the opposite reciprocal, -3/4. And then I'm going to write my equation of my line. Make sure you realize this is the point on the line, not 0, 0. Y minus 4 is equal to -3/4 times x minus 3. Okay? It doesn't say it has to be in slope-intercept form, so I'm just going to leave it for this one. Okay? If it does say it, I'll move it. All right, we have a couple more, and then the rest is for you to practice. I was just saying I'm going to post the practice on Schoology so that you can check your answers. Okay, I don't have them pre-written down here. That's bad on me, but hey, Okay. All right, so let's go ahead and do the last two that we're doing together. It says find the center and the radius of each of the following circles. So if you look, this is not in standard form and it needs to be, okay? So I need it to look like this, right? Okay, so if you look at what this is a binomial squared. So we need to get this to be a binomial squared, and we know how to do that, all right? We learned that last semester. We do that by completing the square, okay? So here's your process for doing that. You're gonna get all of your x's together, all of your y's together, and then anything that doesn't have an x or a y in it, get it on the other side. This is already set up for that. So what you're gonna do is you're gonna complete the square for x, okay? In order to complete the square for x, it has to have a lead coefficient of 1, which it does. So we can go ahead and get started on this. We're gonna do x squared plus 2x, and then we're gonna leave a space to complete the square for x. We're gonna do the same thing for y. If the lead coefficient, once again, is something other than 1, you're gonna factor it out, but that's not a problem here. So we have y squared plus 4y, and we're gonna complete the square for y. And then we have equals 11. All right, complete the square for x. So we're gonna take half of 2, right, half of b, which is 1, and square it, which is 1. So now we just added 1 to the left side of the equation, so we have to balance by adding 1 to the right side. Okay, and then we're gonna do the same thing for y. We're gonna take half of b, which is 2, and square it, so that's 4. And we just added 4 to the left side, so we have to add 4 to the right side. Okay, and now we can factor. This is x plus 1 quantity squared plus y plus 2 quantity squared is equal to 11 plus 1 plus 4 is 16. So there is the circle, and then it says find the center and the radius. The center is -1, -2, and the radius is the square root of 16, which is 4. So fun, I know. All right, looking at the next one right here, I forgot to mention that we know this is a circle. I want to talk about why we know this is a circle, okay? I see an x squared and a y squared, okay? And if you look in front of the y squared, it's a plus sign. So like if you see those things, you know it's going to be a circle, okay? False. They also have to have the same lead coefficient, okay? So if this was a 4 and a 4, it's still a circle. But if this was a 4 and a 1, it's not a circle anymore. And we'll talk about what that is in another day. All right, looking at this one, I know it's a circle because I see an x squared and a y squared, and there's addition separating it. All right, so first thing I have to do is reorganize this one because this one's not organized. I'm going to put all of my x's together, so x squared minus 10x. Then my y's, y squared plus 8y. And then I'm going to get my constant on the other side, equals -16. If there's a lead coefficient on x squared and y squared, you would have to factor it out now, but we don't have one. So I'm going to complete the square for x. I'll leave a space to complete the square for x. I'll leave a space to complete the square for y. And equals -16. All right, complete the square for x. Take half of -10, which is -5, and square it. That's a positive 25. Balance it by adding 25 over here. Take half of 8, which is 4, and square it. That's 16. Balance it by adding 16 over here. So we have x minus 5 quantity squared plus y plus 4 quantity squared is equal to 25. So the center of this circle is 5, -4, and the radius is 5. Okay, looks amazing. I love this stuff. Okay, so what I want you to do, pause the video, try these on their own, and then open up my doc that has the key to this lesson and check those because I didn't realize there was practice at the end. Okay, all right.